And so, great. So let's go ahead and get started here. So the program that we're going to write, it's meant to sort of help someone compute their grade in the class. Okay, so it's kind of something that we're all super familiar with, but fortunately don't have to worry about for this class. We've got a midterm and a final exam grade, so we're going to ask the person to enter in those two grades, and then they're going to enter a whole sequence of numbers for their homework grades. And what we're going to do is then compute the overall grade, which I'll skip down to the bottom here, which, as you can see, here's the formula. 20% of the grade is your midterm, and then 40% is the final, and then 40% is going to be from your homework. And then what we're doing here is we're going to be taking the average of all the homework. Okay. So we're going to sum up, the total homework points, and then divide it by the count, the number of homework assignments. All right. Now, one thing that's kind of interesting, that's maybe a little bit of a flaw in this example, is that, let's say you only did 3 out of 4 homeworks. I don't think this program is going to give you the right answer, right? You'd have to make sure to explicitly put in zeros, otherwise it'll get the wrong number. Okay. So, but let's not worry about that for the moment. Let's just kind of go up and see what this program is doing. Okay, so here's, now what we're familiar with is doing things like cout to print some strings to the terminal, and saying, please enter your midterm and final exam grades. If you remember, I think we briefly mentioned it last time, but if you just have white space in between two string literals, it goes ahead and automatically concatenates them together for you. Okay, then we have some local variables we're declaring here, and then now we're reading in those numbers from the input that someone types in at the terminal. If they type in something that can't be interpreted as a double precision floating point number, then you're going to get an error at that point. Okay. Then after that's done, we say, okay, now submit, enter your homework. And now here's the part where we don't know, as we're the person writing this program, how many homeworks they're going to be. Okay. And that's where sort of this loop comes into play, is that we want to keep iterating, we want to keep reading in sort of the homework grades until we see an end of file marker. So that's a special character, Control-D on Linux or Mac. I forget what it is for a Windows machine. So we're basically just going to keep reading them in. Okay, so kind of getting ready to do this loop, we're initializing our count, the number of homeworks is 0, and the sum, we want to initialize that out to 0. Okay, and then X here is going to represent the current homework grade that we just read in. Okay, so now we kick off this while loop, and the basic idea of a while loop is that you've got what's called the condition of the loop. And as long as this condition, the expression that's here, could be some giant expression, could be something really simple. As long as that thing is true, we're going to keep iterating, we're going to keep executing the body over and over again. Okay? And then we'll stop, and break out and go on to what comes next as soon as that condition is false. Okay? Now, for example, suppose the first thing someone types in is Control-D. And sort of before typing in any of their homework, they just hit Control-D. Then cin, well, it's not going to let you enter this. You're not going to read it in X. And the cin that's returned from this output operator, or input operator, I'm sorry, will be considered false. And you'll just skip right past the loop. Okay? Whereas if someone actually goes ahead and types in some numbers, then you'll iterate once around this body for every number they type in. Okay? Right, and then let's see what happens inside the body. We're incrementing the count. Okay, I think this is a new kinds of expression that you haven't seen before. It's this plus plus operator. And that is equivalent to count equals count plus 1. Okay, so it has the same effect. It's just sort of, this kind of thing, adding 1 to something happens so often that, Kernighan and Ritchie decided to have a nice short operator for doing that. You can also, the plus plus operator, you could use that inside, as an expression. So I could come up with some local variable foo and say that equals plus plus count. It'll get the result of count after the increment. Okay, so let's say count is 0, and then you say foo equals plus plus count. Foo will get 1. Okay. There's another operator. So here, let me, just for kicks, let's say count equals 0. And so foo will be equal to 1 at that point. Now if here we instead go count plus plus with the increment operator afterwards, it's called the postfix increment operator, then what happens there is at this point foo will get 1 again. So it gets sort of the value before the increment. Instead of getting 2, it'll just have gotten 1 there. All right. So that's the case
while it's in the while loop.
So this explanation of what increment does sort of has nothing to do with the while loop per se.
What I'm saying, because it's in the while loop, that's why it gets the number before.
No. Okay, so here let me take this out of the while loop. Okay, just not to confuse things. Okay. So let's say just before the loop. So this has to do with whether it's the plus plus is before or after the variable. Right, so we've already got count assigned to 0, up top here. And then I say foo equals plus plus count. So foo's going to get 1, and count is also going to be equal to 1. Okay. Right? But then on the next line, when we say foo equals count plus plus, the old number of count at this point is 1. Okay? And the new number is going to be 2, if I can type that in properly. But foo doesn't get 2, it gets the 1.
Okay.
All right. So it's the pre-increment versus post-increment. That's what's going on there. All right, let's go ahead and comment those guys out.
Would you say a useful way to understand that would be pre or post that line's evaluation? So pre-increment to that line or post-increment to that line's evaluation, sort of?
Yeah, kind of. Yeah. Or, and maybe another way another equivalent way to have written this out is that you'd say, like, this is like count equals count plus 1, and then foo equals count, right? Whereas the next one is equivalent to foo equals count, and then count equals count plus 1.
Cool. Make it.
Mm-hmm. All right. All right, we don't need any of that for now, though. All right, so now to see what happens so we've covered what this plus plus count does. And in some sense, because we're not assigning it to anything, it sort of doesn't matter whether it was pre or post increment. And then this next statement here is also probably a new operator that you haven't seen before. It's equivalent to, so this plus equal operator is equivalent to doing an assignment and an addition, where you're sort of adding into the left-hand side here. Okay, so this is just going to add the current thing we've read in, the current grade, into the sum. Okay. All right, so that's sort of the main event here. And then the last part of the program is to just go ahead and compute the course grade, right? So we just do some addition and some multiplication, which is pretty straightforward. We do use one special thing here. So we wanted to decide, how many digits to print out. And here we're telling it to use 3 digits in terms of the floating point number might end up with lots of digits, like 4.5773972 or whatever. And so instead we're saying, I'll just cut it off after 3 significant digits. Okay? All right, so let's go ahead and try to run this program. Okay, because that's the end there. Building. Okay, so we're going to enter our midterm. I'm a really good student, so I got 100 on both. And then, maybe didn't do so hot on the first homework, but then got better as I went along. Now I'm going to hit Control D. And Eclipse is, or my Apple is sort of having trouble. Come on. Spinny wheel of death. That's not good. I wonder if it's like they didn't like this keyboard's Control D or something. All right, so this time we're going to try to avoid whatever bug is going on in Eclipse at the moment. And we'll just tell it to loop. How many times? Maybe we'll just tell it to loop for 3 times. So we'll go down here. And we could do something like, instead of putting this here, let's move that. Let's move that down here. Okay. And then we could do something like while count not equal to 3. Okay.
So what is that Cin less than X doing now?
So this is still reading in from the input, but before I was using sort of the input sort of being done with the Control D, sort of signaling like I'm done, and then the Cin turns into false, converts to false in the condition. Instead of doing that, now I'm just saying, keep going through the while loop 3 times. Okay. And in some senses, it might make a little bit more sense if you knew that it was like there were three assignments, then you have to type in a number for all the assignments. Okay. All right. So now, we will run this guy. Keep our fingers crossed. Yay! Course grade is 96. Got an A. All right. So, So what you want to see here is that the count started at 0. The first time through, not equal to 3 is 0. Not equal to 3 is true. So then it went ahead and asked for the 80 was the first number that it read into X, incremented the count to 1, and then put 80 into the sum, right? So sum started out at 0, so now it would be 80, right? So keep doing that till it finally gets to the 4th time around when count is actually equal to 3, and then at that point it'll say, oh, okay, this while loop is done, and then it goes to the end here, right? And then it went into computing the grade, and printed out the 96. Okay.
So then, going back to the pre and post incrementer, if the plus plus was on the other side,
like over here,
correct?
would it matter?
Correct.
The answer is no.
Okay.
Doesn't matter at all.
Because it says it's not updating anything
Right. By the time you get to the next line, next statement, it's going to be updated.
Okay.
And that's well before you get to the condition,
Right.
which is up here, right? So like after executing this line, it always goes back up to the top and checks the whole condition.
Right.
And then decides whether to go in here or whether to pop out the
So
back.
because it goes to the next line, it doesn't make a difference.
Doesn't make a difference, yeah.
Okay.
It's slightly better practice to do pre-increment, though the reason for that is something that wouldn't make any sense at the moment to explain in it.
Okay.
But at some point later on, we'll discuss that. It's a very minor issue.
Okay.
Okay, great. So that's while loops. Okay, let's look at some other kinds of loops. For loops. Let's see here. So last time we did this example where we were printing out triangle, like a triangle of asterisks. So here's how you could do it in a bit more sort of automated fashion. Okay, so what we've got here is a for loop. Okay, it's a lot like a while loop, except that just like a while loop, it has a condition here that controls whether you keep going or not. So that part's exactly like the while loop. Okay, the stuff that's different is that you've got this guy here, this statement right at the beginning, that always executes once right before you kick off the for loop. So you think of it as a way to initialize stuff. And the main use is that you can use it to initialize whatever variable you're using to sort of keep track of how many iterations you're doing. Okay, so in this case, r. So we're setting r to 0. Okay, so then the expression that comes here at the end, that gets executed every time through the loop after the body gets executed. So we're going to execute the body of the loop. So if the condition's true, we execute the body of the loop, which is what I've highlighted, and then you do ++r, and then you go back up and test the condition again. Body, and then ++r, condition, body, ++r, till the condition's false, and then we're just going to pop out and end the program at that point. Okay, so now let's look inside of the body. Well, the body can be, we've got, we're saying it's a statement, so here's one big statement that's enclosed in curly braces. Inside the curly braces, you can have a sequence of statements. The first statement, and here's an example of a statement that doesn't end in semicolon, is another for loop. Right? So this is kind of the neat thing about programming languages, is that typically you can sort of nest things arbitrarily. So you can have statements inside of statements and so on and so forth. So here we've got another loop. This time we're going to be iterating from C, starting at 0, up to r plus 1. Okay? So if you think about it, the r is going to be getting bigger and bigger as we go through this loop, and the c is going to sort of go out and go from 0 to match whatever r is, but with a +1 there. And then we're going to print out these asterisks. Okay? So let's debug this guy. Let's watch it sort of step by step. All right. So notice you can see the variable r over here has value 0. And then I'm going to go ahead and tell it to step. Okay, the condition is true. 0 is not equal to 5. So now we're going to dive into here. Okay, now we're kickstarting another loop. It's set C to 0, so it went ahead and executed that first initialization. Okay, and then we're going to go ahead and print out our first star. You'll notice that it didn't appear yet down here because it hasn't decided to flush the output buffer yet. Okay, and then we're going to, let's see here, we're going to step again. Oh, it popped out of the for loop, right? Because it turns out, so at that point, C was 1, R is 0, so 1 is equal to 0 plus 1, right? So then at that point, this guy was false, and it just jumped down to the end here. And now we've got our endl. Oh, Good, now it flushed the output, so we have a star. Okay. Now this time around, R is 1. Okay, and C, well, C is 1. That's like garbage left over from last time, right? But as we go into this loop, notice C is 0. Okay. Okay, we're going to print out that guy, and now we're going to stay in the loop this time because we're going to keep going until we're greater than 1. But now we pop out. So this time we got 2 dots. Okay. Now we still haven't gotten to 5 yet. Now I'm going to kind of just do this quick. 3 times. Going super fast now. 4 times. And our final iteration 5 times. Then we break out of the outer loop as well. And we're done. So indeed we got our triangle of asterisks. Okay. Any questions about the for loop?
So what are compulsory arguments, like the 3 of them, are they mandatory or?
So the 3 arguments to the for loop, are they all necessary?
Yeah.
Yeah. And if you didn't really want to have all 3, then the thing you'd want to do is fall back on a while loop. Well, or I should say, you could just leave this blank.
Yeah, that's what I was asking you.
Yeah. So let's try this out. Pretty sure this works. Let's tell it to build. Yeah, so that worked fine. Though at that point, it's like, well, maybe just use a while loop instead, if you're not going to have all 3. It is fairly common to see a for loop without the initialization part. So, oopsie, oh, I hit the wrong, darn it. I hit like the expose button or something. So it is fairly common to see for loops that look like that. And the reason is that you might need the R for some later loop, or you might be using it for multiple things. And so then you'd want to declare it, outside of the loop. Like that. One thing you'll want to watch out for is that the scoping rules, if I remember right, they may be different from C or C++ or what version you have, in terms of when you actually have the guy inside of here, whether it's just in scope for the for loop or whether it's also in scope afterwards. I've seen it behave different ways on different compilers and things, so this is where you have to worry about portability sometimes. So you wouldn't want to have like another loop with R. Again, you might use a different variable. Okay. All right. Any other questions about the for loop?
And then again, the pre or post for the counter makes no difference.
Right. So in these counters here and here, it doesn't make any difference. Yep. All right. So let's move on to talking about vectors. Okay, and so this next example, it's almost the same program, except that instead of printing out the mean, or computing the grade based on the mean, right? So we were taking the average of all the homeworks. This time, for whatever reason, the professor decides that he wants to take the median instead of the mean. Okay, so if you remember your statistics, the median is like the middle value. So if you've got like all your homeworks written out and you sort them, and then if there's an odd number, then you take the middle one. And if there isn't an odd number of homeworks, then there is no middle one, but then you just take the average of the two closest to the middle, right? Okay. So by the way, here's an example of a while loop that that doesn't have the curly braces. It just has the one statement after it. But I'm going to change this to avoid the bug that we've been seeing in Eclipse.
Oh.
Let's move this out again. We'll do 3 again. Okay, so if we want to compute the median, well, if you know the description I just gave, we have to be able to sort the numbers, and then we have to be able to sort of find the middle. And so last time we just sort of read the numbers in and added them to the sum and then sort of threw them away, right? So this time we need to sort of store all of them. And this is where vector comes into play, okay? So vector is a class that's in the standard library for C++. And so if you look up at the top here, I've done a pound include of the vector header file. Okay? So some other kind soul, wrote that code for us and created this class. One thing that's kind of interesting about this class is that it's actually what we call a class template. Okay, so it's sort of like it's actually like a whole bunch of classes, and you get sort of a different class for every parameter you put in. So here we've got this type double that it's trying to show me the documentation or the header file for the vector class. Okay, so the double there is going to say, okay, I'm plugging in this double type parameter to the vector class. Okay, so this is going to be a very special vector class just for doubles. And in particular, if you were to read the documentation for vector, it would say the type of values stored inside this vector are going to have type double. Or if we put something else here, then that would have been what's stored inside the vector. Okay, and so I don't know. Have all of you heard of vectors before? Mathematics is basically just not just one thing, but now you have a whole sequence of things inside of this vector. In this case, it's going to be a vector of double precision floats. Okay. So here again we have this loop. The vector class, just like our string class, has a size method, so you can ask the vector how big it is. It starts out at size 0. Okay, so we'll go into this loop the first time around, input a number from standard input, and then here's another method call on our homework vector. So we'll push back. What that does is it makes the vector longer, and it puts whatever it is that you're telling it to put at the back. Okay.
It's like extension and concatenation.
Right. It's just extending by 1. Yeah. Yeah.
Okay.
By 1 element. Okay.
Okay. Cool.
Now, so that'll iterate through. We'll fill up our homework vector with like 3 numbers. And then down here, this is code to handle the case where it could have been an arbitrary number of times around the loop. And for example, if the homework so the person didn't type in any homework, if they just hit Control D right away, then that would be a problem because you can't take the median of a 0 element sequence. Okay, so that's what that code was for, to signal an error. Okay. Now here is something interesting. We've got a call to the sort function. This is also from the standard library. Okay, this is comes from the algorithm header. Okay, so if you see here, I say pound include algorithm. That's to get the sort function. There's a whole lot of other stuff in there too. In fact, I think there's several hundred really useful functions in there that you don't have to write yourself. This is great. Because I know the guy that wrote this sort function. Really, really smart guy. Spent a lot of time on it. You may have heard of something called quicksort. It's better than that because quicksort on average is really, really fast, but like let's say you get a sequence coming in that you're trying to sort that's, I forget, there's certain cases where, like maybe if it's already sorted, there's certain cases where quicksort is actually really not that great. Okay, so what this does, this version of sort, is actually like, it's like introspective. It like sort of watches sort of how things are going, and it actually will dispatch to different algorithms depending on how things are happening. So it's like this really smart version of sort. You know, so the point though is that it's great that someone else wrote this, and you don't have to reinvent the wheel. So that I would encourage you guys to like read up on what's in the standard library in terms of, especially these algorithms, so you don't have to do it yourself. Okay. Now, one thing that's kind of interesting about these library algorithms like sort is that a lot of them work on something called iterators. Okay. You could think of iterators, an iterator as something that keeps track of a position inside of a sequence. Here, let me draw a little picture for this. All right, so we have a vector here. And you know, maybe it read in my homework grades. Oh, right, and never mind this last part because we said it was just going to be 3. So let's call this. So this is the homework vector HW. I'm just going to abbreviate it. So if you say homework.begin, that gives you an iterator, or you can think of it as a position that's pointing at the first element of the vector. Okay. And then if you say homework.end, that actually points one past the end of the vector. Okay. That may seem a little odd to you, but it turns out that when you're reasoning about sequences, a particular convention that works well is to deal with what we call half-open intervals. Okay, so you might be familiar with these from like numbers and stuff like that. So the idea is that, like, if this was like position 0, to 4, the idea is that you include the 0 guy, but you don't include the 4. But you include everything smaller than that. So this half-open interval here is equivalent to 0, 1, 2, 3. Okay. So it turns out that working with half-open intervals is a good way to go. It's definitely, you kind of want to stick to it. If you write your loops in terms of half-open intervals, then things will just sort of work out nicely. And you'll avoid quite a few off-by-1 errors. Okay. So for now, just think of these iterators as being things that let you point to certain positions within a vector. Okay. And so the way sort works is, well, it asks you to give it an iterator that points to the beginning and the end of your vector. Okay. Now, let's say you wanted to, instead of sorting the whole vector, if you only wanted to sort half the vector, well, then you could like, for example, say n minus 1 or n minus 2, or you could sort of move, you can use these arithmetic operators to move the iterators around. And so you could sort of use different iterators then with this algorithm. Okay. So having the sort function that works on iterators is more flexible than, say, let's say you just had a sort method on vectors. Then you'd only be able to sort the whole vector, and you wouldn't be able to sort parts of a vector. Okay. So this is super flexible. All right. So once we've got it sorted, then we want to be able to pick out the middle of the vector to find the mean. Okay. So I'm going to take the size, divide by 2. That's what we're going to call that our mid. Okay. Then we're going to check to see if we had an even or an odd number of elements in our vector. Okay. So this % symbol here is the modulo operator. right? Or you can think of it as giving you the remainder. So you're going to take the size, divide by 2, and get back the remainder. Okay, if the remainder is 0, then it was even. If it's not 0, then we must have had an odd number of elements. If it's odd, then we're in the easy case, right? We're just going to extract out that middle element from homework. Okay, so here's a new syntax for you guys. This bracket operator is how you can access sort of the ith element of a vector. Okay. In math, that would oftentimes be like a subscript or something. And it's zero-based, I should emphasize that. So if you said homework of, if you said homework of 0, that would give you the very first element in the vector. Okay, but let's leave it as mid. Okay. If it's not odd, if it's just even in terms of the number of elements, then we're going to take the mid and then the mid minus 1 and then take the average of those, right? Add them up and divide by 2. That'll be our median. Okay? And that's that. The rest is the same. We're just going to compute. But this time we're going to take the median down here instead of the average. All right, any questions about that so far? Okay, let's go ahead and try to run this guy. So again, it's asking for midterm and final. Okay, and it's asking for our homework grades. And this time, it's the same as last time, 96. But let's maybe, how about I do one that's got a different middle, a different median. Right, so what if I did 80, 80, 100? Okay, course grade is 92. Right, so this time that median here is 80, and then so it's going to be 80, and then with the exam grades, it comes out to be 92. All right. So again, just sort of the picture. So when you're talking about vectors, you want to have a picture like this in mind, where you've got sort of a sequence of things. Then you can access, you can use the bracket operator to access individual elements. You can use begin and end to get at these iterators. And we'll talk more about iterators in some of the upcoming lectures. And then and you can use like the dot size to see how long it is, and dot pushback to add elements to your vectors. Okay. All right, so let's sort of finish up with our remaining minutes with an exercise. Okay, so part 1 of the exercise is to write a function that takes in a string and returns the reversed string. Okay, so for example, let's say the input is hello. Let's call this rev. Then I want the output to be OLLEH. Okay. So that's sort of part 1 of the assignment. If we just get part through that, that's fine. So this is part 1. And then part 2 is I want you to write a palindrome recognizer. Okay? So a palindrome well, it's usually a sentence that you can reverse, and it says the same thing. But here, we're just going to simplify things and we're just going to think about character sequences. And so, for example, the string taught is a palindrome because you can flip it around and you still get the exact same sequence of characters. Okay. Or like, how about Otto? O-T-T-O. That would be another palindrome. Okay. So those, you'd want to return yes for those, but let's say it was toy. That's not a palindrome. All right, so let's take like a couple minutes to try to write out that first function that does the reversal of a string. It should take a string, as in string, as input with a lower. That's with a lowercase s, by the way. Okay.
Can you operate on the characters in a string as elements in a vector?
Yes, that's a good question. Yes. Yeah. So you can use the bracket operator on your strings, just like vectors, and you get out a character.
That's perfect. Okay.
And you can also, this is something I didn't show you guys, but you can assign into using the bracket, right? So like not only can you say homework mid and get the value out, you can also say homework. You could, let's say you wanted to assign a new value into that, you could do something like that as well. Yeah, so you can sort of think of strings as if they were vectors of characters. I mean, it's not literally true, but it's sort of the same idea. All right, maybe let's go ahead and bring it back together and see what kind of ideas we have. So here's the solution that I wrote, but I'll be curious to see if anyone had some different ideas about how to do it. And maybe we'll even... So the main idea with this solution is that we're going to sort of iterate through sort of half of the string and sort of doing a swap from the front half to the back half, right? So we're, or it's probably easiest to draw a picture here. The idea with this solution is that you've got your string that looks like this, and so the idea is you're going to swap those two guys, and then swap these two guys, and swap these two guys, and so on, until we get to the middle. And at that point, we'll be done. Okay? Did anyone have any other sort of algorithmic ideas about how to do this? Did anyone have that one?
I was just going to store the original and then pull them one piece at a time from the back and put them in the front.
Sure. Yeah. That could work. Yeah. I'm not sure if it would work particularly well with a vector, because you could use like pushback. I don't know if string has a pushback method. This might be where they, one of the things that they differ, which is actually kind of lame. But instead of pushback, you could do like you could use like concatenation. You could use like the plus operator, or the plus equal operator is even better to do that with a string.
Right. Yeah. I was just going to create a vector and then fill it using the indexing.
Yeah. Yeah.
But yeah.
Yeah.
Better.
Any other? Did you have a?
No, I just did the similar thing. Like, I thought you just have to print, so I was just printing the opposite side.
Oh, you were thinking about just printing them that way.
Yeah.
Okay. Yeah.
Like going in the other direction.
Right. Going from back to front. Yeah. Cool. Yeah. Okay. So here's the solution that I did here. So we have a reverse function. It takes one parameter that takes a string named s, and it's going to return a string. Now, the algorithm that I'm using is sort of like an in-place algorithm. It's going to be updating the string that it's working on, but I didn't want to sort of change the input string. Actually, you know what? This is a good point. I didn't want to change the input string, so I'd made an explicit copy. However, that was completely unnecessary, because when you pass a parameter in like this, it makes a copy already. Okay? So I just made 2 copies for no good reason. Okay? I was probably up too late last night writing this code. Right. Now, there are other ways of passing parameters that don't make copies of things. So I've put an ampersand there. That's what we call pass by reference in C++. At that point, it doesn't make a copy of the string. It's just sort of passing sort of the address of the string along. Okay? But it's sort of, the fact that you've got an address here is sort of under the hood, because then you can use s later on exactly as if it's a string and not a pointer to a string.
And so would you pass by reference if you just had a really large argument that you were passing?
That's a good thing. And that's the main, there's 2 reasons for passing by reference. One is you've got a really big thing, right? So if you have some giant string, it's going to take a while to copy that sucker. So that would be a good pass by reference. Or if you actually want to change the thing that you're passing, then pass by reference is good for that too. Now, suppose you don't want to change it, you just want to make sure that there's no copy. Then what you can do is you can say const string ampersand. So this is now a const reference. You're not allowed to mutate or do anything that changes something that's const. Okay? So if someone sees like const reference, you should be thinking to yourselves, oh, they're doing that just for performance reasons. They don't want a copy to happen. Okay? Either performance in time or space. It might be that the string is like the size of your entire memory and you don't want to all of a sudden need to make a copy of it, right? With a string, that's a little bit ridiculous, though. I do know some physicist friends that they buy a certain number of machines for their supercomputer because they know that the problem they need to solve is going to fill up exactly their entire machine, right? And so in those situations, you don't want to make extra copies of things accidentally. Okay, so we've got this pass by reference. So then here I'm making a copy of it. Then here I'm iterating through, half of the string, and then here's the logic for swapping. So it turns out swap is a standard function that's in the standard library, because it turns out that people need to swap things quite a bit. Swap takes its arguments. Well, actually, let me guess, or have you guys guess. Do you think they're sort of normal by copy? Or it's also termed by value, is the technical term for that, or by reference? Without looking at swap, can you guess which it is? Or const reference? What would make sense?
By reference.
by reference. That's the only one that makes sense. If it was by value, then since it's making copies of these things, it can't change the original things if it's only working with a copy. And if it was const reference, again, it couldn't change anything. So swap really would only make sense if it takes its parameters by reference. Okay? And then at the end, I just return R. Okay? So I think the nicest way to write this is to just use S all the way through. I save a line of code there. Okay? So that's the reverse. And then here's the main program that does the palindrome detection. I go ahead and read in a string from the user. I then call reverse to get the reversed version of the string. And then I check if the original guy is equal to the, oops, I should have just said this is wrev here instead of wasting time doing it over again. And then if it is, yes, it's a palindrome, or no, it's not. So let's just run that and we'll conclude for today. Yes, tot is a palindrome. Of course, we have to test it with the other alternative. No, toy is not a palindrome. Great. All right, that does it for today. Any other questions? Oh, by the way, of course, you didn't have to use swap. You could write swap out yourself. You know, it's only 3 lines, so it's not that big of a deal. But you could access, you know, put something in a temporary variable, then assign it to the other way, and then assign the temporary back to the other one. So that might be worth doing yourself once, just to sort of, it's a common idiom that you see, so to get used to it. All right. All right, thanks a lot.